In the late 1990s and early 2000s, enterprise computing lived in physical rooms. Companies like Sun Microsystems built the heavy hardware that quite literally kept the internet running. When a component within one of these massive server racks went down, system administrators didn't have time to carefully disassemble things. They needed to unlock, pull out, and replace the heavy hardware modules in seconds. That speed relied almost entirely on the design of the rotating latches mounted on either side of those removable modules. The engineering team had to ensure that the mechanism to release the drives was as frictionless and intuitive as possible. In high-pressure IT environments, the reliability of a multi-million-dollar machine often comes down to how quickly a human can operate a tiny, unglamorous latch. The engineering team was on a strict schedule. Building physical, working prototypes of these metal latches would take several months, but manufacturing decisions had to be made immediately. So they did what any agile design team would do. They used paper prototyping. They printed out 2D drawings of different latch configurations, showed them to system administrators, and asked them to imagine how they would interact with them. Curious, this schematic shows the clear favorite that emerged from those testing sessions. It's a symmetrical layout where both latches rotate inward toward the center, exactly like the hot and cold handles on a standard bathroom sink. Looking at the survey responses, the team had everything they needed. The users had clearly communicated their preference, the visual logic made perfect sense, and the data pointed to a single, intuitive choice. They locked in the design. Several months later, the machined metal prototypes finally arrived. The team put the actual hardware into the hands of real system administrators and watched their intuitive design immediately fail. Every single person who tested the physical latch tried to turn one side of it in the completely wrong direction, jamming the mechanism. The paper tests had missed one critical variable. You didn't turn these latches with your bare hands, you operated them with a screwdriver. On the left is the visual symmetry of the faucet handles, but on the right is human instinct. The moment you place a screwdriver into someone's hand, their brain abandons visual cues and defaults to a deeply ingrained muscle memory, lefty-loosey, righty-tighty. Because the faucet design required the left latch to turn counterclockwise and the right latch to turn clockwise, users were forced to fight their own physical reflexes. And because manufacturing was already underway, redesigning the latch would mean redesigning the entire server chassis. The flawed hardware had to be shipped. The engineers hadn't collected bad data, they had collected irrelevant data. They meticulously measured how users imagined acting in a vacuum, entirely disconnected from the physical triggers of the server room. This vulnerability in product development is something the Japanese automaker Honda recognized decades ago, prompting them to build a philosophy to prevent data delusion. This structure represents their core principle, known as the 3 realities. The foundational layer is Genba, physically traveling to the exact location where the activity or problem is occurring. Once there, you move to the second reality, Genbatsu, carefully observing the tangible conditions, tools, and environment present in that space. Only after those 2 steps are complete do you arrive at the peak, Genjutsu, collecting the quantitative data and information to support your decisions. While typical corporate cultures often obsess over that top layer, the raw data, Honda treats it as secondary. They recognize that metrics and surveys cannot stand without the heavy anchor of physical context. If the Sun designers had applied Genba, if they had simply asked the administrators to hold a real screwdriver while looking at the paper drawings, the conflict would have surfaced immediately. Moving quickly to test ideas with cheap, low-fidelity mock-ups like wireframes and paper sketches is absolutely still the right move. But to do it safely, you have to follow 3 rules. First, acknowledge the bias. Every rough prototype lacks something. Before accepting user feedback, you must clearly identify exactly what physical, spatial, or emotional context your simulation is missing. Second, re-verify at every stage. As a product moves from a rough sketch to a polished interface or physical object, those added details can easily break usability that seemed perfectly fine a week earlier. Finally, context is king. It's tempting to test an app in a quiet coffee shop because it's convenient. But if your software is designed to be used by paramedics in the back of a moving ambulance, testing it in a cafe will give you perfectly accurate answers to the wrong questions. In the rush to iterate, shortcutting physical realism will ultimately shortchange the final product, because in design, data is only as valuable as the reality it is grounded in.